Yeah. Thanks. Okay. Let's go ahead and get started. This is QUIC. If you're not here for QUIC, you're in the wrong room. If we could ask the folks coming in to close the doors, that would be helpful. Thank you. So this is QUIC. We have one session in this meeting. Lars, my co-chair, wasn't able to make it to this IETF, so he's going to be joining us remotely. I'm flying semi-solo. Also, our area director, Spencer, is remote. As you can see, we have a lot of other remote people as well on MeetEcho. So please keep that in mind. When you're at the mics, speak clearly, state your name. Let's not have side conversations, and let's make sure that they can productively participate. This is the Note Well. Hopefully by this part of the week, you're familiar with this. These are the terms under which you participate in the IETF, or a summary thereof, really. Regarding intellectual property, regarding your behavior and how you treat other people. And copyright and lots of other things. So if you're not familiar with these, please do a search for IETF Note Well on your favorite web search engine, and you'll be able to find this document and understand what you commit to when you participate in this process. So Joe has very kindly offered to scribe. Many, many thanks for that heroic duty you're performing. The blue sheets are on the sides. If we could start circulating those. And once they get to the back, if you could please send them to the center so those folks get a chance to sign in as well, that'd be great. Our agenda today is pretty tight. I'm going to try and keep things snappy. We're going to have some updates from the base draft editors. We're going to touch base with the operational draft editors. We're going to discuss some of the issues on the base drafts. Excuse me. And talk about the foreseeable future, what we plan for the next steps for the working group, what our status is, how we think we're going to finish this work. And then if we have time, we have a last minute addition to the agenda, which is an update on the spin bit work from Marcus. Any bashing of the agenda? Okay. So, first up, we have a quick update from Martin. I'll attempt to get your slides up. Oh, look at that. Come on, you can do it. Okay.
Oh, look at that.
No. Okay, there you go.
That works. Yes, apparently we have 16 by 9. So next, I'm going to make this really quick. So this is basically the things that have changed in the last, it was an anchor and no longer. So probably the biggest change that has happened recently is the Stream Zero special crypto thing has turned even more special and no longer consumes Stream. Ian's going to go into details about that in a little bit. So we'll move on. Next. It looks like a lot's changed in 13, and that's because a lot has. We added support for ECN. Thanks, Magnus, for all of the extra work that was put into that one. We've made changes to connection ID handling. That's not the end of that. We're discovering now that connection IDs are interesting and complex and new ground, and breaking that new ground has turned out to be a little bit painful. Mike's got some more on that later on. We added the ability for servers to advertise a preferred address on which they would like the connection to migrate to. We made stateless reset symmetric, and we now actually can extend QUIC in various ways, specifically new frames in this case. There's a bunch of changes to HTTP, QPAC. I think we're up to 01 on QPAC, which means that we're still a little bit early on that one, and so that's had a lot of churn. Next, please. So when I wrote this, which was last week, we had about 100 open issues. We still have basically 100 open issues. We've been killing them pretty quickly, but they've been popping up just as quickly. This is a considerable improvement over where we were 6 months ago, mainly because we've gone through and labelled about half of these as parked or version 2. And for those people who are not familiar with the way we're dealing with this, we've identified a bunch of issues that we're not going to solve now. And those are still open in the issue tracker, but they're labelled with the Quick V2 label. That basically means, yes, we think this is important, but it's not important for us to solve right now. A bunch of other issues are labelled parked, and those ones, oh, thanks. Those ones, we're sort of committing to come back to them later. And that might be because it's the spin bit and we haven't finished our work on that, or it's because we need more information, or because we just can't solve the problem right now for various reasons. Of those remaining, which by various measures we have somewhere between 30 and 50 issues, my assessment of these, and I think the other editors are in agreement on this, is that they're pretty close to done. And the main reason that they're not done is because it takes work. And if anyone can help us out with any of this, that would be greatly appreciated. And so we're going to be looking to assign work to people over the next little while. But from my perspective, the end is in sight here. And it's just a matter of sitting down and typing. Some of these will require some discussion in the working group to reach conclusions. Some of them, the conclusions, at least to me, seem fairly obvious, but we'll discover interesting surprises along the way. But they're relatively minor for the most part. And so I expect that we'll be able to have something fairly concretely complete by the next time we meet here at one of these plenary meetings. So, the end is in sight. That is the light at the end of the tunnel.
No, it's not. Thanks, Martin. This is my nightmare every night.
That is the light at the end of the tunnel. That's all.
That's all you got? Okay. Any questions for Martin about the status of the drafts or the recent changes? Let's not get into issue discussion, just any questions about this subject matter?
All right. Yeah, Ian's going to talk about Stream Zero, and we might have some more details about that.
Yeah. Okay, thanks. So next up on the agenda is Ian talking about Stream Zero. While we get ready for that, I skipped something, I apologize. John was going to do a very quick update of what happened on the weekend with the hackathon. You just want to use this mic real quick, maybe?
Jana Iyengar, very quickly, we had a hackathon. We had a number of people show up and participate, some remotely. Implementers were, there were some people working on draft 13, but many were still working on draft 12. I heard some mumbling about trying to get packet number encryption right here and there, and people are still seem to be working on that. So I think it'd be nice to actually move forward to Stream 30 to draft 13. Draft 13 is a big shift from what we've done in the past. Draft 12 already includes packet number encryption. Not everybody's gotten there yet, but hopefully by the next interim, people will be on to 13 and working on Stream 0 issues instead of being stuck on things before 12. Eka.
So one thing I wanted to add here is if you go to the GitHub, I believe Kazoo has produced a PR that has a, not Kazoo, but Kazoo has produced a PR that has a example client hello with a, or at least an example message, I assume is a client hello with a PNE. And so that was, you may find that to be a useful structure for figuring out why your PNE doesn't work. I'll try to get Mink to make one and dump out all the intermediate points, like a crappy version of Martin's draft, because like that does like it's very helpful to like have that kind of stuff. That's a one case where like basically you can just ingest the message with no state at all and like run and reproduce exactly the crypto everybody else had. So that may help people get PNE working, because PNE I know is a little tricky for people.
Okay, thanks.
I'm just hoping one last thing that if people, as they're implementing P&E, can find out the simple gotchas that they got stuck on, be useful to add them into the draft. So please keep note on that.
Okay.
That's about it.
Thanks, John. Just for folks who are new to this or haven't been following closely, we have a very active group of implementers. I think we have, on the order of 10-ish implementations right now. We've been meeting before in the hackathon before the main IETF meetings, as well as adjacent to our interim meetings, and they use a Slack group to communicate. If you're interested in all of that, please get in touch with me or Lars or any of the editors, and we can introduce you to that effort. So Ian, Stream Zero.
All right. So I'm going to do a summary, mostly of what we talked about in Chista. So if you were there, then this is pretty much just a rehash. I am going to go fairly fast, just because most of these issues are fairly decided, but I want to kind of go over them because Martin in particular is going to talk about some of them later. Next slide. So this is literally still kind of a copy-paste of sorts from London. These are from accurate slides about the various issues with the Stream Zero design at the time. So next slide. I'm not going to actually, these are mostly for reference. As a background, TLS over TCP, you have TLS messages on TLS records, and those may or may not line up with TCP segments. So a TLS record can span multiple segments, or it can line up, or there could be multiple TLS records within a segment. That's sort of the architectural model. In the next slide, in the draft 12, which is prior to the Stream Zero changes, this is sort of the quick stack. As you can see, it's a little more complicated. You have TLS messages that are on TLS records that are inside quick frames that are inside quick packets, which themselves have kind of a record layer, as we'll talk about in a moment, inside datagrams. So at the very least, it's probably one extra level of indirection here. Next slide. So draft 13, the design that is otherwise known as the quick record layer design, kind of squashes this down by one layer. And it makes it so the TLS messages are in quick frames, which are then in quick packets, which is sort of the crypto record layer for the transport. And this was already very much how 1RTT and 0RTT worked anyway. So 1RTT and 0RTT, there was no TLS record layer involved, unlike TLS over TCP. So in some sense, this is like a unification of the design we already had, where before it was kind of half in one world and half in another. So next slide. We added a new crypto handshake frame. So instead of actually putting it over Stream Zero, there's a special frame. It removes a few features, like you can't fin it because you never really wanted to be able to fin a crypto stream. There's no stream ID because that doesn't make any sense. And each encryption level restarts at offset 0 to avoid any ambiguity about what happens if the start offset of the next encryption level is before the end offset of the previous encryption level, and various other weird things. It is not a stream frame, so therefore it is not flow controlled by default. We discussed that briefly in Chista and decided that the effort to flow control it was more effort than it was worth, and if we did want to do that, that would potentially be a TLS working group item. Next slide. So the new approach has clear rules about where every handshake message is sent. There's no double encryption. Quick doesn't really need to know anything about the TLS handshake stake. Basically keys get exported and TLS says send this at this encryption level, and vice versa. Quick passes messages and data back to TLS and says this was received at this encryption level. Yeah, no double encryption, and you also get built-in path validation. So before we actually had path challenge and path response, and they were allowed during the handshake because we didn't have a good way of actually making sure that the peer was on path. But now the receipt of anything at the second encryption level, well, technically the third EBOC in TLS, but of handshake encryption actually proves that you're on path. So in practice, you don't need a separate on-path validation. Next slide. So where are the costs? It basically requires a new API for TLS. That's probably the largest cost, at least that we're aware of. Obviously, it requires a few changes to the quick drafts as well. But at this point, there are already some implementations available. And at least the interrupt thing is actually a little bit old. I think there might be 3 people who have interrupt now, but I'm not sure. So, next slide. Huh?
The comment was 3 or 4, he thinks, from Ecker.
3 or 4. So another change we made at the same time, there were some issues around not having separate packet number spaces. In particular, there was an issue that Christian identified a long time ago where by spoofing a unencrypted packet, you could essentially create a hole in the peer's packet stream, and then they would never be able to recover from it for the rest of the connection. And that hole would actually be in the encrypted portion of the packet number space, not in the unencrypted portion. Kind of the details are on issue 1018. But the critical thing that needs to happen is when you get an acknowledgement, you need to know whether that packet, what encryption level that packet was at, that this is being acknowledged. So you need some unambiguous way of knowing, this peer is acknowledging 5 and it was at this encryption level. The other issue that was open is that acknowledgement of packets at 1 level could actually, at least in the current loss recovery doc at the time, cause spurious retransmissions of packets at a different encryption level. So you could, receive a initially encrypted packet, and that could come after, say, 0RTT. Maybe you can't process 0RTT. Suddenly you acknowledge the initially encrypted packet, and fast retransmit kicks in and says, like, oh, this peer must have lost all the 0RTT, and you retransmit it anyway, even though the real problem is you just couldn't decrypt it. And so therefore you couldn't acknowledge it. Next slide. So the design for separate packet number spaces is basically you send an acknowledgement or an ACK frame in the packet number space you want to acknowledge. So there's no special ACK frame or a new ACK frame. It's just, ACK frames in initial, acknowledge initial packets, ACK frames in handshake, acknowledge handshake packets. You can't send ACK frames in 0RTT because there's no point. And 1RTT ACK frames obviously acknowledge both. Actually, they acknowledge both 0RTT and 1RTT packets. So next slide. So it solves the issues we identified. It clarifies exactly what level you should be sending your acknowledgements at. Before there was some very weird wording and kind of confusing wording about you should always try to send the acknowledgement at the highest possible level, but you could actually end up in a situation where you could acknowledge a packet, but the peer couldn't actually see your acknowledgement if you sent it, for example, with 1RTT keys, because even though you received a 1RTT packet does not actually mean that the handshake is completed, for example, on the server side due to head of line blocking of the CFIN. So it also makes the rules quite simple. So the rules for recovery for all the different packet spaces are pretty much identical. There's no special cases like if this is at this encryption level, do this, and so on and so forth. And yeah, it removes some temptation to do some relatively stupid optimizations that we came up in the meantime with. And the more we went through them, the more we realized they were foot guns that would get you in a heap load of trouble. Yeah, so next slide. So the big cost is basically data structure cost and tracking cost. So I think the logic is fairly straightforward, but you do need, at least temporarily, to potentially keep around multiple kind of ACK frame data structures. You may need to keep around multiple sent packets data structures. And the other cost is you're going to end up with more of what we call coalesced packets, previously referred to as compound packets, where you have 2 QUIC packets in one UDP datagram. So, next slide. So transport retry. So this wasn't really in the original list, or this kind of got baked into the original list of comments about issues with Stream 0. But in this process, it also became clear that there was a desire to have a non-TLS kind of retry stateless reset mechanism that's much more similar to TCP SYN cookies. And this is mainly for DDoS reasons. So the idea is that there really should be a really easy way to do proof of source address that doesn't involve consulting your TLS stack or doing anything complex. And in some cases, people actually wanted to put these separate boxes from the main host. But there's also the issue that the current retry that we had before complicates TLS interaction. There were some fairly confusing rules about whether you had to send an HRR in a retry packet or not. And in general, no one was really super happy with the state of the world. So the goal was to move retry into the transport. And that has largely worked out well, but there are a variety of detailed issues that we kind of didn't fully think through when we first wrote up the text. So next slide. But I'll go over the design here. So the retry is not encrypted at all. So it's just plain text. It's a long header packet. It actually repeats the destination connection ID that was in the client's initial. And the reason for that is to do proof that is on path, basically. And then it has token content. And so the server sends me a retry, has a token in it. I put that token in the next initial that I send back to the server. And then in theory, this token is proof that, I am on path and I am the IP that I say I am. And as you can see, the initial has the token content kind of right at the beginning, right after the long header. Yes, and the other issue is that this token is actually also used for 0RTT. So there's a new token frame inside the encrypted envelope that allows you to refresh a token once you're forward secure. And of course, you must not mix these tokens. So, tokens that are used in the handshake and are used for basically DDoS prevention, must not be used later for 0RTT. Next slide. I kind of went over these before, but retry minimizes CPU usage on the server side when under DDoS and other attack situations. And it generally simplifies the interaction for the stateless reject use case. So, and there's no packet type ambiguity about where you put things. Next slide. All right. So these are the issues that are currently open. In the initial description, there were a lot of things that were intended to be written down and just were not written down quite right. So draft 13 just has a bunch of little errors that thankfully Martin mostly fixed at this point and did a nice job of. But then there are a few other issues. And at this point, I might as well just let Martin talk about these. I assume that's next.
Not quite.
Not quite. Okay.
A bit later. Yeah.
Well, coming soon to slides near you. All right, that's it.
Thank you, Ian. Any questions about the Stream Zero transition? I've heard a few from folks about how this might affect our schedule. We'll talk about that a little later in the session, but anything else? Okay, thanks, Ian. Next up, if I can figure this thing out, we have, I believe, Brian, if you can make your way up, talking about the operational drafts. Good on you. Clicker if you like. Okay.
Hi, I'm Brian. For those who haven't already asked, I have said skiing accident. Here to talk about two drafts, IETF quick manageability and IETF quick applicability. Do I have the?
It may.
It may work. It does work. Operations drafts. Does anybody remember these? We actually forgot about them for a while, and we're the editors. The point of these is to provide advice to application developers and mapping designers on using QUIC, right? So we are chartered in this working group to work on one application mapping to HTTP with HTTP2-like semantics. This is, however, a general purpose transport protocol, so we'd like to have sort of either template information or other considerations that you have to have when you're mapping something other than HTTP2 onto QUIC. And then we want to have another document, which is advice to application and network administrators, network management tool designers on what deploying QUIC is going to mean for management tasks that they commonly do. So the idea is to say sort of a user's guide to the QUIC wire image for people who are only looking at the wire image, so they don't have to go into the protocol itself. So this is really the fifth focus area in the working group charter. Applicability, we updated it this time. We made basically no changes because there had been no text added to it since the last time. We just revved it to keep it from, or to unexpire it. We'll talk a little bit about the scope of this document because I'm not sure we have it quite right. Like, so originally we had one document which was applicability and manageability, and we decided to split those in part because one looked like it was going to be done way earlier than the other one, just, you know, with respect to the amount of discussion we needed to do. We haven't changed as much, but there's been like no controversy, so there's been no attention, right? Like, so it's like, okay, great. We'll take a look at the open issues and talk about how we might want to scope, if we want to rescope this in a couple of minutes. In the meantime, we've done some thinking about manageability. The flux in the wire image. So as we've been developing the protocol, basically trying to track changes in the headers was completely pointless, so we just didn't do it. It looks now, especially after CID, PNE, and some of the stream zero interactions with the wire image, the retry stuff, that's all settling down now, so it's time to basically write it up. And we did some of that for this time, but we'll need to do at least one more rev on that. So the changes in 0.1, we updated to the Rev 13 headers. We added coalesced packets, we fixed CIDs, we encrypted the packet number. This actually allowed us to delete a lot of text because we were talking about what the packet number might be used for, and it turns out now it can be used for absolutely nothing. We mention SNI for application identification. So when SNI gets encrypted, we may have to tear that back out too. We point to the experiment for on the spin bit for potential RTT measurement, and also point out that you can do initial RTT based on the handshake. So those dynamics have not changed. Like all of the names, the packets have changed, but that point hasn't changed. There's a little bit more work to do on load balancing and usage of the connection IDs, but it's our opinion as editors that this document at that point is mostly done, right? Like, so the protocol has a relatively minimalistic wire image, so the user's guide to the wire image is here's what you can do with it, not much. That's by design, right? There may be some commentary that comes into that where we, you know, talk about why not much, but in terms of the technical content, this is pretty close to done. We looked at the open issues, and pretty much all of, like originally I said, okay, well, I'm going to classify these by applicability and manageability, and then the manageability list in terms of open issues on manageability that we need to actually talk about is empty. Classifying the open issues in the applicability draft, we have sort of three classes of these. One is endpoint implementation issues and endpoint API issues. So this is a little bit less about writing bindings and more about what sort of interface the transport protocol should give to the layer above, right? So we originally envisioned this as a document where it'd be like a binding writer's guide, and it turns out that we almost, a lot of these issues came from discussions on the base drafts, and they were sort of shunted over to the ops drafts. And it looks like there might be, from these issues, some demand for some sort of abstract interface document, whether that goes in the applicability or abstract interface specification, whether that goes in the applicability document or has its own document, is something that we should talk about. There's a second class of these, which are sort of additional endpoint behaviors. These are, you know, pointing out things that you could do, right? Like, so there's a, do we want to talk about the fact that you can use streams and stream resets to give you an emulation of partial reliability? Do we want to talk about multiplexing over, like some multiplexing multiple sets of streams over CIDs on the same 5 tuple? Talk about trade-offs in whether or not you do keep alives or decide that you're going to do RTT or zero RTT resumption when you have a NAT state drop. And then the third of these are sort of operational guidelines for serving quick. So this, I put a question mark on applicability here because they're currently filed as probably on applicability, and they were in the original scope of applicability, but it also seems like, you know, yeah, right? Yep. So there's a scoping question. For the open issues that we know belong on applicability, Mary and I, we can suggest text, but we might not be the best potential authors for some of these. Like, so some of this is like version rollout and rollback in large clusters and migrating Google Quick to Quick, right? So people who have experience with that, I'm not looking at anybody in particular, might have you know, better input than we have on that. If you look at one of these issues and would like to assign yourself to it, that's graciously accepted. PRs are also graciously accepted. I wanted to have a bit of a talk now on document organization and audience, especially on applicability. Because right now we're talking to implementers, we're talking to sort of clients at the application layer, and we're talking to deployers with that document right now. And it might be that that's too much, and we might want to split this out into a third document. We might want, if we're doing too much, we might want to push them all back into one document, right? I mean, there's, since we're picking this work back up now, and hope, you know, that manageability should basically be done in the Bangkok timeframe is my optimistic hope. Okay. If we stop changing the wire image, obviously. And then applicability is done as soon as we get text done. But since we're going to spin that work up, we should talk about the organization now, I think.
Okay.
Jana Iyengar. So I think when we talked about the applicability document a while ago, the application layer users and deployers were sort of important and core parts of this. What for implementers are you doing in the document? I don't see anything in there that I think of as a piece for implementers, really.
So a little bit kind of CID generation, port number use, right? Like, so not necessarily like directly implementation level stuff. There was actually a discussion about how to handle ICMP quoting, which got pushed over into the ops drafts and then got picked back up in the base drafts because that's actually where it belonged. But there's still some stub stuff about like, so handling ICMP, what your error interface should look like. So these, I think, are things that are really talking to implementers.
Also, this touches really this touches the point about the interface discussion, because the interface needs to be implemented by the implementers and then used by the application, right? So, and it currently the document gives hint about where an interface should be, but maybe want to say more than that.
Yeah, I think I personally think the transport interface that you were talking about earlier is an important piece of this. I think it's something that we should really try to get done. I think that's probably, to me, the most important piece of this one. And then the users, the questions on zero RTT, how do you deploy this? Those are important, but not as important as the immediate API.
Do you have an organization opinion? Do we put all of this into applicability, or do we take, because the interface stuff really, it's almost a disjoint audience as far as I.
Yeah, it's tempting to think of it as a separate document almost. Okay.
When I looked at these issues and I was trying to classify them, that really was the feel that I got. I'm not trying to like load the question, but I'm interested in other opinions.
So the way I think about this is, if it's valuable to, as you start writing it out, if it starts becoming too big, split the document. That's usually something I think about.
Okay, I saw it. Yep.
Because I don't know how big it's going to get. I suspect it's going to get big.
Yeah. Yep. Yeah.
So, Gori Fairhurst, I think there's a very different audience between people wanting to do an API and use this, to those who are trying to run an operational network and want to know how it's behaving and what packets are important for them. And the detail's probably not in your list, the detail's in how you write it.
Right.
So we should be careful as we write it that we pick the audience, because experience at the IETF is people, if you direct it in the wrong way, that group of people won't read it. So I think there are two different groups of people who you could write the text for.
Okay, so that's the split between applicability and manageability, right?
Yeah.
Okay.
Tommy Polly, Apple. I would just like to reiterate what I think you and John have been saying of the actual abstract interface feels like it should be a different document that can certainly reference this. So I think this should describe all of the bits that are required to give a more normative claim about what an abstract interface should be, but that should be left for a separate exercise, which I think we should also do soon and start working on.
Is that volunteering to edit?
Yes.
Okay, cool, thanks.
We'll talk to Lars about that a bit more. I guess now that we're having a chat at the table, we're chartered right now to deliver these documents at the same time as the base protocol. It occurs to me that a lot of the folks who could contribute to this work are right now heads down on that work. Would it be beneficial, do you think, to maybe just delay these documents' publication by, not work on them, but publication by even just a month or two, so you can get a little more of their free time?
I would say I would suggest basically like one interim cycle, right? Like, so a half meeting cycle is probably enough, right? Like it's 1.5 months, right? Well, we're gonna talk later about the milestones.
We'll get into fine details.
Yeah, so X plus 1/2 cycle, I think is good. But
if these documents weren't to ship at exactly the same time as the base drafts, that's
fine.
Okay.
Yeah.
Ted Hardy, let me just make sure I understand what you're proposing before I come in, because it was a little hard for me to hear. Mark, what I heard you say was you were proposing that the publication of these drafts might be later than the publication of the protocol drafts. Is that correct?
I was asking if that would cause pain. I wasn't proposing.
I think it might cause pain. Speaking personally, I'm particularly concerned about some of the operational guidelines aspects coming later than the protocol documents. In particular, because we're putting the protocol documents out once we've got significant interoperability testing under our belt. I'm concerned that people will then almost immediately start using these. In fact, some people are already starting to use these, and that those guidelines might be useful earlier rather than later.
I think the trade-off is just the quality of the documents could be significantly better if we have a small delay.
I agree, but there are some core pieces to both of them that I think it would be very valuable to have come out as close as possible. So perhaps some more discussion on list of which pieces might get more attention so that we can get those out early might be useful.
Okay.
Can you stay a second, Ted?
Ted.
Mia Kulevan. I agree. I think they should be published at the same point of time. But for me, publication is like when the editing phase is finished and we actually have the RFC published, right? And I think that can be aligned. Like even if we send it to publication for the IESG at different times and so on, we can then at the end like wait until we publish the RFC.
I don't want to get too deep into the planning of this. I just wanted to see if there was amenability. Obviously, we need to talk and think about it a bit more.
Yep.
Okay.
I think we're good.
You're good.
Well, I'm gonna put people on the spot a little bit. Show of hands. Who here sees one of these open issues that they believe they could help with? That's not committing. I'll close my eyes. Okay. Yeah. So yeah, a few that will. Okay. Good. All right. So we'll basically follow up on the list with the heavy guild, I guess.
Yes.
Cool. All right.
That's the tool you have at hand.
Excellent. Thanks. There's stairs over there, right? Or
Yes, on that end. Yes. Thank you. Thanks, Brian. Okay. So next up, we're going to go into, if I can figure out this thing, discussion of open issues on the base drafts. The editors have selected 6 different topics of areas they have questions for the working group and clusters of issues. We're going to go through those. We want to leave some time, as we mentioned before, for planning and future-looking kind of planning. At the end of the session, we also have the presentation on the spin bit. So I'd ask we not let any of these sessions get much more than 15 minutes long. If we do that, we should be okay. First up, Martin, we've got retry. Sorry? Yes.
Mark,
Yes.
I'd like to agenda bash that a little bit. We have a pattern of discussing for 15 minutes and then deciding, oh, well, now we're like moving on the next thing. I'd like to close some of these issues rather than just be like, oh, we spent like 500 messages in the mailing list discussing retry. So I'd like to get retry done rather than, I don't care. If I don't get to I don't know, connection ID, management, that's sad, but I'd much rather get retry done than get retry and connection management each quarter done.
So, Martin, Jana, from your standpoint,
Yeah, I think we should do this one first, then connection ID management.
Are these in priority order?
That list there is completely random.
No, that is random. It's retry, then managing keys, then stateless reset, connection IDs, HTTP, and recovery.
Okay, let's do that.
Is that a good ordering?
Let's at least stick with that. And
That's, as I understand it, a summary for the HTTP working group, not a decision-making
So
session.
Mike points out that there's a couple of issues that he wants to talk about. So
Yeah.
There's
This is separate. Yep.
we want to solve some problems here.
Okay, so let's get started.
Yep.
sounds good.
Let's not talk about talking. So, oh yeah.
I need slides. Sorry. Do you?
Let me,
Yep, that one and then that one. Yep,
yeah,
we're good.
okay.
I'm just going to get straight into this one. Okay, so we have a retry so that we can do the stateless client address validation stuff that Ian was talking about before. It's token-based. It's pretty simple. However, we identified a whole bunch of issues around this. So there's some spoofing problems we've talked about for a long time. The format was looping zero RTT interactions and how you do coalescing. So let's talk through this. So the summary, Ian talked about this one. The client sends an initial, the server sends a retry, it's got a token in it. The client puts that token in its next initial, and we continue along with the pattern. Interesting point here is that because the server chooses the connection ID that the client uses, the connection ID from the retry packet is in the subsequent initial packets. A property that was a little surprising as a result out of the Stream Zero design team work was that retry can be sent multiple times. So there was a number of deployment scenarios where it was necessary to do this, and so we can have a number of round trips going back and forth with initials and retries and initials and retries, and you're not actually making any progress, but you're just going back and forth.
Colin Perkins, as someone who hasn't been deeply involved, what's more surprising is that initial can be sent more than once.
In fact, you can send initial under all sorts of conditions, and it's crazy.
It's a very confusing name.
I'm sure we can paint that bike shed any color you like, but that's not important. Okay, so first issue was that the format was a complete mess in 13. At the top there's a little picture of the octets that we have in the format in 13, but there was an observation that it is basically impossible to decrypt and decode one of these messages because of the way that the packet number is encrypted and of arbitrary length. People have pointed out this is a bit of a problem. We did this because we wanted to have some consistency between the long header format and the short header format, and we just missed the fact that we dropped some of this information into the wrong place. Also the point that retry apparently included a packet number, which was apparently encrypted, but we don't actually know how. And so there's a proposal out there that's got a lot of positive feedback, and we simply just reorder the packet around, and we don't include a packet number in the retry message. The consequence of that is that we can't coalesce retry with anything else, but then we don't actually have any need to do that as far as I'm aware. So I'd suggest we not worry about doing that. Now is your opportunity to tell me that I'm crazy and this is a bad idea, because I haven't merged the pull request yet, but I fully intend to, because we've got a backlog of things behind this change. All right, sold. And next, so because we have this multiple retry packet interaction, there's actually no reliable way at the client to distinguish a retry in response to their first initial or the second one. And there's an interesting problem here. If you retransmit your initial, as you might have to do, you can get multiple retries coming back. And ultimately, with varying delays on the network, you can get retries from the first initial mixed up with retries from the second initial, and you don't know which one is which, particularly when connection IDs aren't actually changed at the server end. So the suggestion is that if the server doesn't intend to proceed with a handshake, or it might not proceed with the handshake after this initial, it has to provide a new connection ID. It must be different to the one that it's received. And it's got to be of a certain size. I mean, it's relatively straightforward. Just gin up another random number and shove it in there. That's not particularly difficult for a server to do. And there's no reason for it not to do that. But this means that every single retry that you receive will have a unique value for this original destination connection ID that you see. As a result, you can identify which initial it is responding to, guaranteed, as opposed to maybe in the past. And so in the case where you have a packet that's retransmitted from the client that arrives after the client has sent another initial, you can distinguish between the one that's just echoes from the past and the one that's actually a response to your currently outstanding initial on this connection. So that fix is also in that PR. So we're moving on. Feel free to get up if you disagree with anything here. So spoofing. It's relatively straightforward to spoof a retry if you see an initial. Basically, all we have there is the randomized destination connection ID that's in the initial packet. If the attacker can see that value, then it can generate a retry. There's no other proof from the server end that it's seen the packet. There's no encryption on this. There's nothing fancy like that. This can cause connection failures, particularly if an attacker decides to spoof these things, and they can successfully do so multiple times. The client's eventually going to say, this server is sending me infinite retries, I'm going to give up. And Kazuo had identified an interesting one where you can have the attacker effectively spoof a retry and propose a different connection ID. If they strip the token from the subsequent message. If they're able to strip the token from the subsequent message, then because they're man in the middle, ultimately what the real server will see is something that looks like a real initial, but it's actually got the attacker's choice of connection ID in it. Not sure what you're going to do with that, but that's just what it is. John?
On the previous slide, if you could, are we here saying that the server infrastructure has to basically provide unique original destination connection IDs across all devices for this particular set of retries?
No. So the destination connection ID that the client's ultimately going to use is either one that is randomly generated for itself, or it's one that the server randomly generates for it.
Right.
And really the only requirement here is that the values are unique across this one particular exchange. There's no requirement for them to be globally unique or anything crazy like that. Of course, they're really big random numbers. Chances are they're going to be unique anyway. So that's
adequately
fine.
Unique.
It's adequately unique, yes.
Yeah, no, it's just even if it's that's fine with me.
I wouldn't even bother checking for collisions. I'd just gin up a new random number and move on.
Yeah, that's probably the best recommendation then.
Yep.
Thanks.
Kyle Neckritz, if we are allowing this kind of spoofing, does this make retry part of the invariance?
It's none of the invariance we're promising, but maybe it's one of those things that we're not actively clamping down on. Yeah. So if you think about the way that we've done invariance, is that we've made there's a wire image that QUIC version 1 has, and that wire image has a certain set of properties, some of which we're actually guaranteeing that we'll maintain across into version 2. This is not one that we're going to make that promise for. No, I don't. It's not in the invariance draft. It doesn't need to be. The main reason we have invariance is so that we can maybe one day ship version 2.
So I guess what I'm saying is, if we're allowing anyone on the path to send a retry, it may very easily become an invariant.
Yes, ossification is a real thing. Yeah.
So, I mean, I'm starting to think that we went off the rails when we decided that the ODC ID was the thing that proved that was in that correlated the request to the response, and And we did that, I think, because people were sad about scraping pieces of the authentication tag. But like, you know, there's a lot of like mechanics here going on, trying to like basically substitute the CID for a random challenge value. And like, we already have a random challenge, we already have a random value in the packet, which is like the crap at the end, which we already agreed is like a random value because we're using it all over the place, or the crap after the end or whatever. Like, I mean, there's just like a lot of stuff here that like you could work with. And I mean, or for that matter, you could use the enciphered PN from the which is also now random, right? So I guess I'm just like making a lot of rules about. I'm just like starting to get really sad about making all those rules with the CID when like actually we have other entropy in the packet we be exploiting, and all we're really trying to do is round trip.
So we discussed this on the issue, and I know you raised this point, and for a couple of people, having to remember the output of the encryption was difficult.
I appreciate that, but I think this is lame. So, you know, I guess my point is like I don't think that's dispositive. I think it's an argument.
Yes, and nor do I think that your argument is particularly convincing on that front either. I think it's a choice we make.
Well, I mean, I think you've like we now have like a bunch of the new complexity about how these are generated, the distinction terminal and non-terminal. The much easier than to do would be to like always if you're a server, which like you want any connection ID at all, like generate no connection IDs. They're gonna be bouncing around a lot. It's just like there's a lot of new additional complexity in the protocol to handle like this case, which can be handled other ways. So
I'm not sure that I agree with that assessment.
Okay, well,
so a server that wants to do this, every time they send a retry, they send a randomized connection ID. That's all they have to do. There's no additional complexity on that front.
I mean, you're assuming that people know whether they're terminal or non-terminal.
No, even the terminal one can do.
No, but the terminal one wants an empty CID.
Why does it want an empty
because
CID?
It doesn't want to waste, because it doesn't need it. It doesn't want to waste bytes in the packet. And so now you have to know the topology of the network.
It's an initial packet. They're always going to be the same size.
No, it doesn't want base size in subsequent packets.
Yes, but the server gets to change the connection ID with its initial. That's the final determination of the connection ID. This is only for the subsequent initials that it's going to affect.
Yeah, I mean, again, this is just comedy. We can screw in connection ID. Like that's even more bullshit. Like, why don't we just like set it properly in the first time the server responds? Okay, I mean, I guess like I'm not sure where to go from here, but like the but
I want to hear from someone else.
Yeah.
So yeah. I mean, if you're the only one who thinks this is a problem, then
what? So far, you're the main person for proposing this, right. So I don't really think we're like let's not polite.
This is what we got, right? So Mike's going to tell us about something else.
No, I mean, I think it's sort of related to this, but like basically right now we have this rule where once you bound to the destination connection ID, I presume that D1, D2, D3 are different destination connection IDs, right? So it's like once you're bound to the destination connection ID in the server initial case, you stick with that connection ID even if the server responds with retransmissions, which are different connection IDs, or coalesced packets or different connection IDs. I wonder why we made the different decision to do retries are special and they're allowed to change the connection ID, because if we bind the original connection ID with retry, then this wouldn't be a problem at all, or mitigated at least. So it's you get one retry which just decides your connection ID, but you can do multiple retries. And as for the spoofing case, so there was one reason there's an explicit reason we allowed for multiple retries was that the hello retry request model of retry was actually subject to the same, like a worse attack. That is, you could do only one hello retry request because TLS enforces that on you. And so, like, two questions, I guess. I don't know. Those are two questions. One was that, like, why don't we just bind to the connection ID at the first one? And the second one was,
if you're going to open old issues that we've already litigated at some length, I think we probably need a little bit more warning for that one. And I'd suggest taking that to the list.
Okay.
Because we have talked about that.
Ian Sweat, Google. I
I think this is fine, and I think we discussed this at length as a proposal. I don't have a particular objection to Ecker's approach in practice, because I do realize that this is only for initial packets. So as long as I only have to repeat like 8 or 16 bytes, saving whatever magic 8 or 16 bytes of the initial is like a special case, and I can just throw that into a buffer. So I don't really have a strong opinion. I understand Ecker's kind of situation where you're forced to change the connection ID. So in our case, I think we probably will never actually use multiple retries in our deployment. At least I don't expect to in the near future. So this is sort of like a non-issue from an operational perspective, but aesthetically it's like, it can get a little ugly. I kind of agree. So, but I don't really have a strong opinion. So, but it'd be fine. It's not causing me any pain. Yeah.
We've got Tommy, Martin, and then we'll get into the remote queue.
Awesome. Tommy Pauly, Apple. I agree very much with Ian that I can kind of live either way. This is a little bit convoluted seeming, but it seems like a perfectly reasonable way to solve it. Ecker's proposal also would be fine. The point I wanted to make was that as I had, I think I gave you feedback during the hackathon, I think we need reworking of connection ID text in general. And what would help a lot for this is if we just had a more clear section explaining the best practices around connection ID and the overall philosophy for it. That would help, because I think the disagreement I see here is kind of around what is this connection ID about, when should we be generating them, and if we have more of an introduction to that, it may help come into this convolution a little bit more clearly.
Yeah, we've heard that, and the editors plan to do a fairly.
So I think this just raises the requirement for that section even more.
Yeah, I think that doesn't really engage with the core question that Ecker was doing. I mean, we can explain better, but ultimately the concern there is that we're overloading this in ways that are maybe not ideal.
Can very quickly interrupt? That is an open issue in the applicability document. I mean, we can discuss if it belongs there, but...
Whatever the applicability document says, the transport document has to be coherent on connection IDs, and currently it's not ideal. So we plan to fix that.
Martin Seemann. I'm fine.
A little closer to the mic, please.
Closer. Speak up.
I'm fine with this proposal as well as with Ecker's proposal. What I'm worried about is the spoofing. So Middlebox could advertise that as a feature that it does source address validation, and thereby add a round trip to every quick connection. And there were a couple of proposals how to prevent that, basically by putting stuff into the handshake to validate that no man in the middle did a retry. And I think we should go with some of those solutions.
Okay. Nick Banks is next.
Can you hear me?
Yes. Little letter would be good though.
Sure. So I'm against using the AAD tag.
Nick, you're breaking up pretty badly. Can you take it to Jabber and we can channel you from there?
Can you hear me any better?
Yeah, turn your video off.
Any better?
Yes. Yeah.
So being able to use the tag assumes you have easy access to it. If you're using something like encryption offload, the quick server or the quick client that would have to validate that wouldn't have access to that very easily. So the CID is something that has a lot of direct, easy access to, and think it's the best solution.
But you need the tag for PNE, don't you? No. Eric Wascorla. I mean, you need the ciphertext for PNE, which is the same location as the tag, right?
Well, I mean, if you offload all the encryption, essentially the code, it would just pass down the unencrypted value. The hardware could do PNE and payload encryption, so it would have never had access to whatever that AAD tag was.
Yeah.
To do the validation later.
Yeah, it's true. It was pointed out to me separately that this is actually a consequence of a decision not to encrypt retry, and had we just encrypted retry, our generic solution would work. So I think what I'm really sad about is we don't have a generic solution for this that doesn't seem like a lot of custom screwing around. So I agree, my solution isn't dramatically better because we had one and we've abandoned it.
Okay. Thanks, Nick. Oh, did you want to respond to Nick or? We're asking
Well,
questions.
riffing off of that, the retry that we have doesn't need to be version independent. And if this is happening after version negotiation, we could say that retry is a version dependent and therefore encrypted frame.
It's already version dependent, yes. So we can do
why not
whatever we
encrypt
want
it?
with it. That's not the problem. We can decide to encrypt it, but the conclusion of the design team was that they didn't want this encrypted specifically.
Okay.
Because that was for that would make the implementation of the offload and whatnot far more efficient.
Yeah, my understanding is that this was basically the point was to be as close to what am I thinking about, the SYN spoofing? Yeah, to be able to do this cheaply when you have DDoS attacks. So encryption would be considered a cost that they don't want to bear.
All right. That was Mike Bishop and John Iyengar, by the way. So let's get back to the queue. Martin Duke is next.
Yeah, I just wanted to comment that if the point of Ecker's solution is to case fix the initial has to be padded out anyway, so I'm not sure what the actual savings are.
Did you want to respond to that, or?
Yeah, no, I agree. It's not about saving bits. I just think this is unaesthetic. So I guess if what I'm hearing is that like people by and large are neutral, and like there are some people who like think that that I'm wrong. So in the interest of like getting forward, okay.
All right, thanks. We had some talk about spoofing. I think the suggestion that we validate the choice of connection IDs that we used to start out with is probably a good one, and we should look at doing that. I've heard this from a number of people now. Oh yeah, this was the proposal that I have. So, two options. So we don't actually make any promises about success of handshakes or whatnot in the presence of an attacker that has the sort of capabilities that we're talking about right here. So specifically, we don't prevent attacks during the very first phases of the handshake from an attacker that can see the client hello. It's possible for an attacker to generate a server hello that a client will accept that won't necessarily ultimately result in a successful handshake, but we're not doing anything special. Once the attacker has man-in-the-middle capabilities, then we're not taking extraordinary steps to protect.
Can you characterize what the attack you're concerned about is here? Because this is not the attack. This is not match the attack I thought you were concerned about.
So the only attack that I'm aware of here is that the attacker gets to choose the destination connection ID that is attached to the client initial packet that ultimately reaches the server.
Sorry, this is a off-path or on-path attacker?
It is a man on the side would be able to mount that attack, yes.
Okay, so right. So just to make sure we're on the same page, the requirements on the previous slide, I guess 2 slides up, sorry. So
Yes.
the requirements on the previous slide plus a minimum entry requirement for the DCID or the SCID actually from the initial obviate any off-path attackers from
Correct.
providing this attack.
Yeah. So one of the things we agreed to do was ensure that you had to be able to see the packets in order to do any of this. Off-path attackers don't get any leverage over this modulo. The probability of them being able to guess one of these things pretty low. So we have agreed previously that we would not do anything special in this case. So maybe we do nothing.
Igor
Yeah.
Igor Lubashuk. Just to make sure that people realize that an attacker with the ability to see initial packets, handshakes, they can even attack you at version negotiation stage. In fact, even to a point of replying with "we speak no such version, go away." So that's they can disrupt things even before client initial and things like that.
Exactly right. And so we ultimately concluded that until we have a shared key with someone that is authenticated, attackers with these capabilities can do just about anything to disrupt that.
Jana Iyengar, I largely agree, obviously, with that sentiment, but I'll just note that this is a slightly different flavor of attack, and it's because it allows a man in the middle to basically direct all traffic towards a particular server potentially, because it's able to restrict the connection IDs.
So this is probably something that came up in the conversation, and we ultimately concluded that an attacker does not need to bother doing this in particular, because if they wanted to go and do that, then what they would do was it would be far more efficient for them to act as a client and simply set the same connection ID on every request that they sent to the server. So I don't believe that to be a problem. This is probably advice for the applicability/manageability documents, that if you're running a server, maybe you shouldn't be using the connection IDs in the initial packets from a client to determine routing. Because in that case you could have a very large population of clients that send all their packets to the one paltry little instance sitting in the back end that suddenly gets overwhelmed, and then they could do that, they do that one and then they move on to the next one and kill that and so on. So there's an attack there. So that's more interesting actually.
Yeah, there's an interesting case where the 4 tuple might actually have more entropy than the connection ID.
Yeah.
Like in this particular attack. But it's definitely worth documenting, in, I think, in the security considerations and in the applicability document as well.
So the proposal here, I think we probably want to separately discuss the idea that we might authenticate the destination connection ID that's originally chosen. But the proposal here was basically, we're not going to do anything special, but we would suggest that maybe clients that see an initial packet could use that, even if they've reacted to a retry, just in case it's spoofed.
So I agree that there is no security concern about this, but there is some authentication concern, because a non-pass device could always force the client to use the same connection ID, and that effectively eliminates the reason why we AES encrypt for obfuscation. Because having a static key means that there will be no obfuscation at all.
Right. And so the point there is, if you can force someone into using the same keys, then you don't get to ship the next version of the protocol, because now they're ossified around that particular key. So it's an interesting point and probably motivates the suggestion that Martin had. I'd like to come back to that idea later. I think we don't have time for that now, and I haven't looked at that yet. Okay, so another thing that's on the list of PRs that are about to be merged, largely because I've gotten a lot of good feedback on this, is the question, what happens if you get a retry what happens to your 0 RTT? And so the proposal here is, well, yes, you can send 0 RTT again. And Eka's analogy there was, well, TCP fast open didn't work, but you would still be able to, in TLS, do 0 RTT at that point. The observation there is that version negotiation is fairly similar in this regard. It's unlikely to work in the sense that if you're changing quick versions, it may not be the case that your 0 RTT ticket is any good for whatever you do in the new version, but there's nothing inherently prohibiting that. The rationale for this was, well, we don't have any strong justification to say that you can't try 0 RTT, so we'll allow it. There's a catch. It's unlikely that the keys that you're using to protect 0 RTT packets will change as a result of having received a retry and effectively starting again. And so there's a requirement in here that when you get the retry, send another initial, start sending more 0 RTT, you don't reset the packet numbers back to 0, because 2-time pads, they're awesome. And so that's the primary reason. There was another reason, I forget now what it was, but the 2-time pad thing was the primary concern here.
Though you could technically retransmit the exact same packets, that would be fine.
Yes, but we generally advise against that.
I advise against it, but it would be technically okay.
It would be technically okay. And so there's the observation in the PR also points out that there's a very good chance that the 0RTT packets that you sent last time might be lost, but they might get there. We don't know what servers are going to do. So,
yeah, so I was about to bring that up, but could we actually say that if you get a retry packet, then the server has officially said that I'm not committing to state anymore? That would be very convenient to say clients should retransmit 0RTT data immediately, and very clear semantics in that regard.
The PR basically says, yes, you should expect to have to resend them, but it doesn't say should, because a client might decide not to continue with 0RTT at that point. That's entirely up to them. There's no interoperability cost to going either way on this.
Well, I'm not sure if you can resend the same packet because the connection ID changes.
Maybe it didn't change. I don't know.
Yeah.
Some servers might change it. So, but yeah, good point.
So I mean, I'd drawn the analogy to TFO, which I thought at the time was a good analogy.
I think it is a good analogy.
But I mean, we also make some noises about how this is conceptually a new connection. And I wonder if the right noises are that you should ditch all the TLS state, generate a new client hello, and then you wouldn't have to screw around with the packet numbers. Because that'd be a different analogy, right? It's just new connection.
That would be fine as well, I think. I suspect that it doesn't matter.
No, I don't think it does. I don't remember like I'm glad somebody caught this packet number reset issue because it's a good. And so like I just worry it's subtle, right? And so I don't think it's a disaster, but it's like something you could easily get wrong, and it would not be, and it would like if you just screwed it up, you'd be sorry, right? So so let's say, I mean, like that would be taking a different metaphor for this. You'd be saying like this is a new connection metaphor, as opposed like it's like you got a reset, like a TCP reset instead of a TFO, but it would be a reasonable way to think about the world. So
yeah, that's a good observation. I think we could allow either one, frankly.
Yeah. So Pat McManus. So I think raising the issue was really great because I had disallowed this in my code because, it's not actually 0RTT anymore after the retry. There's been a round trip, and just intuitively this made no sense. So it's good to clarify. And I agree it can actually be done because it's, now we'll call it one less RTT or something. It's still a win. And I like the with new packet number rule because that is consistent with the overall philosophy that one does not retransmit packets, right?
Yep.
So, and yeah, deviating from that seems bad.
So I would actually suggest that you can keep the same counters for all of the packet number spaces. That would be the way to think about it.
Right. I think like having people resend initial with 0 and then the other things with 52, that's not going to be okay. It's gonna, I don't mean it's going to cause problems. I mean it's going to cause incompetence. So I think either we should go with like the suggestion that we resend the initial with the next sequential packet number, or we should do like what I said about client hello. But I think having this is going to be like sad people.
Yep. Yeah. All right. That's good feedback. Yep.
So Mike Bishop, the other reason that we didn't reset them and something for server-side implementers to be aware of was that if those 0RTT packets were either buffered or delayed, they can arrive after your new initial or be processed after your new initial, and they are still valid for the connection. So you'd better not change the data that send them.
All right. Thanks all. Oh yeah. Same thing. So different angle on the same question. If you get a 0RTT packet and you haven't sent an initial, what do you do with it? Currently, we have a write-up that basically says if you get a 0RTT packet, you must not generate a retry in response to it. You're only allowed to send a retry in response to initial. Actually, the support for doing this is pretty weak. There's not really too many reasons in either direction for this one, but basically, rather than shrug our shoulders on this one, we'll say should not for this one, or may or something along those lines, basically because there's no reason not to do this sort of thing. And it may, in some cases, improve performance if a server receives a 0 RTT packet and wants to keep things moving along. It can do address validation immediately rather than wait for the possibly lost initial packet that the client has sent, because that can take time, far too much time. No problems with that? That's that talk, all done. Thank you.
Okay, thank you, Martin. Please stay there. Stay inside the pink box. Pretty much, yeah. Next up is managing keys.
Oh yeah, that's a good one. Yep,
Yeah.
yep, the long one.
Discarding handshake keys. Sorry, different name.
So this is another one that I think is relatively urgent, although not hugely important. We've had a lot of discussion about how to manage keys, and one of the nice things about the updated design is that it's pretty crisp about when keys are used and what packets are protected with what keys and what cryptographic handshake messages are protected with which keys. But we have this sort of fuzzy bit when it comes to getting rid of those keys. So here's my summary of the handshake. There's a lot of messages going back and forth. You'll notice that there's a lot of coalescence potentially involved in this. But one of the things that you will observe is that that there are initial packets being exchanged for some time, but at some point you stop having a need to maintain those keys. What do you do with that? Well, initial's pretty straightforward. Not a lot of, not exactly secrets we're maintaining here, but still be nice to know when you can clean that stuff up. Same applies to the handshake keys. So you've got handshake messages initially starting from when the server sends its first flight of messages, and ultimately ending when the server sends its acknowledgement of the client's handshake messages. And maybe at that point you can get rid of those keys, except for the fact that we have this tail problem on these things. We never really know whether this halting problem in the sense that you never really know that the handshake is done and the other side is done with the handshake, because acts can get lost and all those sorts of things. So the simple solution for this is to treat each packet number space separately. And you say that the packet number space is done when the read and write keys for that packet number space, read and write keys for the next space are ready. So for handshake keys, when you have your 1 RTT keys and you're using them, then you're done with the handshake keys. And there's a little bit of nuance to that because of the arrangement of the handshake. But at that point, you can just set a timer. And so you set a timer at that point, and that runs for, I don't know, a couple of RTOs, a couple of round trips. It doesn't really matter. It could be a pretty long time. In fact, we've sort of established, because of the way that the TLS key separation works, that you could potentially just keep the keys forever. It's just an overhead. It's memory. They're not actually a threat to anything at that point. But still, you set a timer, and during the time that you're maintaining that key, you'll be able to receive acknowledgements, resend crypto frames as necessary, and send acknowledgements. And so that seems pretty reasonable. Once you've gotten rid of the keys, obviously the packets that you receive that might have been encrypted under those keys will be unintelligible, and you'll just be forced to drop them, and that's probably okay. So the way to think about that is you look at each packet number space, and there's also some consideration here for 0 RTT, but I've got the two kind of critical ones here. So at the point that the client receives the server hello, and at the point that the server sends the server hello, they're basically finished sending crypto frames to each other. And that's the point where they set a timer. And at the point they set that timer, they can set that timer for a number of round trips. And we're just maintaining that timer for as long as we're willing to effectively continue acknowledging things, essentially, or repairing the cryptographic handshake state. And the same applies, I mean, the direction of messages is different, but the same basic procedure applies for handshake messages. You just, when you see the last one, right, set the timer. So there's been discussion of a sort of implicit acknowledgement system for all of this. You can use the fact that you've moved on to the next phase of keys to sort of as a signal that says that the other side has all of the crypto frames from the previous iteration. So if you get a handshake packet, pretty sure that all of the crypto frames in initial packets got to their destinations, because you can't derive those keys without actually having access to those messages. Similarly, if the server receives one RTT packets from a client, that means that the client has received all of the crypto frames that the server ever might want to send. It's a little more tricky on the client end for one RTT packets, because the server sends them before the client's really done, or it could at least. And so the client actually has to look for acknowledgements of its one RTT packets to signal that. And in that case, you can stop sending the crypto frames. Now, of course, what will happen is that there's a potential for ACKs to be lost, and you'll have acknowledgements in flight, and you might potentially want to do some more acknowledging at that point. But you can actually safely drop the ACK frames if the other side agrees that this is acceptable. There's a couple of corner cases in this, and I don't think we need to worry about that. Someone's going to jump up and tell me that's wrong, but that's, I'm not planning to document that optimization, by the way. I think people who want to embark upon these sorts of optimizations will have to think through the consequences of all of this and be absolutely certain they're not going to break the other side. There are models that you can use for this that require that the other side is aware of what you're doing, because what will happen is it will think that it needs to retransmit crypto frames, and you don't need them, it doesn't need them, but it's resending them and expecting acknowledgements. And if you're dropping those packets on the floor, you could end up with crypto frames being sent for a considerable amount of time after the handshake is well done. And it's just wasteful at that point. So there's a little bit of care required in order to get this logic right. I'm not going to write that down because it's too damned hard. A number of people have suggested that it would be nice to have a signal that the handshake is done. That is a positive signal once you get the one RTT keys from maybe from each side, but I'm thinking probably from the server, although I've shown it in both directions here, that basically says, I'm done with the handshake. I have everything I need in order to proceed with this connection. And once you've received that message, you can stop sending any packets on the previous packet number spaces. You just throw everything away at the point that you receive that message. Ian.
I was going to comment on the zero RTT keys. I think you could probably drop those at the same time safely, because you're sending zero RTT in the first flight, and by the time the handshake done would be sent, that would be in the client's second flight, so you'd still allow for a full RTC of reordering of zero RTT packets. That seems totally sufficient.
Right, and so that's an interesting observation. Yes, it doesn't perfectly solve the problem, but at the point that you're an entire round trip after the zero RTT keys have been done, it's not quite that good, I don't think, because the handshake done is sent in close proximity to the last of the zero RTT messages. So I don't think it's as good as you think it is.
This is the client server handshake done, right?
Right.
This is in the direction of the server. So the server, when it receives handshake done, will receive that handshake done basically, sometimes I imagine, in the same packet as zero RTT.
No, I think it's a full RTT later, right?
No,
it's not. It's not.
Now, so because in order to allow streaming of the zero RTT data, the client continues sending zero RTT data until it's processed the entire server first flight. And so basically the last, essentially the last zero RTT packet is sent milliseconds before the CFIN.
Yeah.
So I mean, now you're in like timer. I mean, now you can do it. You know, I mean, all that's going to happen is you're going to have a lacuna in the data, but like you want a timer. I mean, a smart implementation want a timer for that.
Yep, and we're back in the soup. So this is my proposal. Document that you might want to clean up the keys. Suggest that you might want to use a timer for that purpose, and leave the rest of the optimizations for those people who want to have fun debugging thorny key management issues. I don't care.
So, Mike Bishop, I will point out one of our other open issues is now that we have an extension framework, we're looking for a poster child extension to exercise it. Handshake Done would be a fine extension.
I don't think it would be, but I mean, if you want to use that as a safety valve, and for anyone who wants it, nothing's stopping you from proposing it, I guess.
David Skenazy, Apple. Just want to say that I really, really agree with this mentality. There are already too many things in the spec that like sound a little bit too smart sometimes, and as an implementer or first reader, you go, wait, what is going on? So if people want to go crazy and optimize something and maybe document it on the side, that's fine, but keep it out of the main spec.
Kazuhoku, I'd like to point out that people who prefer
Can you move the mic?
Kazuhoku, people who prefer having handshake down could implement the same facility using ping frames. So I don't think that we need a special frame for that.
Right. That's the optimization that I outlined essentially. Yep.
Subodh, I agree with this as well. In the previous iteration, before the Stream Zero proposal, that was be more dangerous to do this. But now that the separate ACK spaces and separate packet number spaces, it's like much cleaner and much safer to do this.
Yep.
Eric Riscola, I also agree with this. The one thing I would say is that the text does need to clearly state when it is safe to do this. I mean, it has to say like the last time, in the sequence, the last packet which you will get with this is here. I'm happy to assist with that text.
Yep, that'd be great. Yep.
Yeah.
Sorry, so just to be clear, your proposal is that we don't actually say, would you like that to have like, here is a set of timer rules which you could follow, or just you may wish to use a timer and this is when this is the time when you should be setting the timer if you were to set it.
Yeah, and basically acknowledging that once you've hit this point, then it's all about retransmissions and acknowledgements, and you set the timer based on how long you're willing to spend retransmitting things and acknowledging them. But
yeah. I was going to drive it even the simpler version of that. I mean, if infinite is okay, we might just need some essentially non-normative text that acknowledges, that there is some point at which this happens, and you may or may not make use of that fact. I don't think we even need to set timer values in particular.
I'm not going to suggest a specific value. No. That's that deck. So thank you.
Great. Stay there.
I'm stuck in this pink box. I don't have dreams about that.
Next up is stateless reset.
Oh yeah. Yeah, we have those, don't we?
Every time it's, oh yeah.
So this is one that will never die.
Oh.
That's all right. All right. So Mikkel made an interesting observation. Turns out stateless reset is by design indistinguishable from a quick packet. You can't decrypt it. No one can decrypt it. That's kind of the point. But it's also the case that you send stateless reset when you receive a packet that you can't decrypt. And both client and server can do this. It doesn't actually take a client and a server to produce this problem, because you can certainly point to servers at each other if you really wanted to do that. So that's a little bit of a problem. It looks like this. There's no amplification. So if a packet gets lost, it eventually ends. But I hear that some people are operating networks that don't drop packets that often nowadays. And I'm not sure that I want this problem. So, we've discussed a couple of simple solutions, and it's not really that dire a problem when you think about it this way. It turns out stateless reset is pretty small. It's variable length for various reasons, but it's pretty small. And so it'll be smaller than most packets that you're going to receive. Certainly most packets that you sort of receive that you don't know. Obviously, there's already rules in there that if the packet's too small to plausibly be a quick packet, you're just going to drop it on the floor anyway. So maybe we can be, don't send it if it's smaller than the packet that was received. If it isn't, correct. Thank you. I should proofread. I'm learning that my proofreading skills are
Are you having trouble with a double negative there? Or?
Yeah, double negative. Only send it if it is smaller than the packet that was received. Thank you, Mark. There's also a slightly more complex solution that says, well, maybe it's nice if you send a stateless reset in response to these packets, because if someone is, say, doing, let's for instance, telnet, and the first packet that they send after a long idle period is Control-C, it's a single character, and that's going to be a small packet, and your connection ID is small, there's a pretty good chance that you will have this packet be relatively small coming in, and wouldn't it be nice if maybe they had at least some chance of being able to benefit from this little optimization that we have that will kill the connection off. And so you have some sort of probabilistic dropping. And as long as that probability is not zero on dropping it, then everything should ultimately resolve. Yeah, you'll get a couple of legs on the a couple of bounces in the sort of perverse scenario where both sides have lost state and have decided to statelessly reset each other, but it'll ultimately resolve itself. And so I think that's a reasonable solution. And that's all I've got on this deck. Did anyone have any questions or suggestions or disagreements? I wanted to get this in front of people who've got a little experience with this one.
Just one. My name's Tim Shepard. Just one simple observation that there are networks that rarely drop packets, but there are also networks that occasionally duplicate packets. And some of those might duplicate packets somewhat more often, even though it's rare, somewhat more often than they drop packets, in which case you have to choose A and B. I mean,
a little more care is required, is just what you're suggesting?
I don't know what the answer to this is. It's just a thought I had. I thought I should
Actually,
share.
that's a good question, since we have so many people in the room who might actually know things about this. Does anyone have any idea what the duplication probability would be in those networks relative to the drop probability? Because we could at least provide some guidance there.
There are a lot of weird networks out there. There may not be the norm of the internet, but I couldn't possibly tell you what numbers are for every weird network that exists out there.
Yeah, so weird is the norm. So I guess we'll have to make some allowance for that.
Let's hear from non-editors for a second. Corey, why don't you go ahead?
So, Gori Fairhurst, I mean, there are networks that actually drop packets due to AQM and other things, etc. And there are networks that duplicate packets for odd things. So the question is, do you want to work everywhere in the internet? Or do you want to work on just one part? So it's a trade-off for you. Numbers won't help you, I'm afraid, because there's always going to be this tail end of stuff that is really weird.
Yeah, but if the drop probability is high enough, do you think? Well, I hope that. Yeah, maybe we could get you to look at it and say whether or not you believe that this is a problem.
Sure, I explain it in a way I understand a little bit more clearly, and I'll try and help. The question is, can you be robust to this, not optimal?
Yes, yeah, that's really what we're looking for. Yeah.
Are you Jabber channeling, David? Yep. Why don't you go ahead?
Thanks, David Skenazy, Jabber. Relaying. So two people. Praveen Balasubramanian wanted to say that randomization makes it very hard for debuggability. Let's keep things predictable. And Mike Bishop was saying that acts are another. Oh yeah, why did Praveen ask me to relay you? Anyway.
Yeah. I'm going to continue to ask the editors to let others cycle through, and we'll let you guys have maybe the last word. Eric?
Eric Nygren, I think a key thing here is making sure that whatever we have is very deterministic, that this ends fast, because even if they're the same size, if an attacker can induce this ping-ponging by injecting something, that two endpoints start ping-ponging back and forth, it doesn't matter that the size, that they're small packets and not increasing in size. It's that ping-ponging itself. If they just keep injecting things, you start having a growing set of stuff ping-ponging. So you want to make sure that ends.
The proposal here was not, if they did not decrease in size, you would drop them. So it would always be strictly smaller.
Right. And I guess that might be worth thinking through. Are there any cases where you can trick things in ways of various formats might make it look to two endpoints that they're different? So for example, if there's some encapsulation or translator in between that is going and adding a little bit of stuff onto them, so that between those two endpoints, you get something with that violates that property. So maybe we're thinking of is it worth having something more explicit here that really guarantees that it terminates fast.
Okay, over here next. Over here.
Tommy, so I'm not sure if this will help, but I'm wondering if there's another tool in the toolbox of things we can do to help here. I understand that the stateless reset is stateless, but can an endpoint carry some decaying state of the number of resets that it has been sending and essentially just have some plausibility? Like, you could very easily say that if within the past 10 seconds I've sent a ridiculous number of resets, I've detected that there's some ping-ponging and just stop doing it for now, just back off. And actually have that drop rate be relative to the amount that you recognize ping-ponging possibilities.
We do actually recommend something along those lines, yeah.
Go ahead.
Am I next? Okay, so Jonathan Lennox, I mean, my first point is, does it actually have to be that the condition is that the packet is, smaller or equal to a stateless reset, or could it just be if it's exactly the size of a stateless reset? Because obviously something smaller can't be causing the ping pong either.
So they're variable sized.
They are variable sized? Yeah, all right. And the other point I was going to say is, in the case you're describing of the telnet, even if your probability is quite high, like 50%, you're still going to almost certainly get a stateless reset within 3 or 4 RTTs. So yeah. I think this probability, if you want to do it probabilistically, I think it can safely be quite high to cause a very fast decay. And in most reset cases, you'll get recovery within 2 or 3 retransmissions.
Yep, that was my intuition as well.
I have 4 points. The first point is, let's remember it is an optimization. It is not like it is a nice optimization, but it's optimization. The second point is you must do some bookkeeping anyway of how many stateless resets you sent, because otherwise you end up like sending a crap ton of stateless resets, like for like the enormous flood of packets that are coming in. And I believe real implementations is going to say do this anyway. So like since you have to have some bookkeeping anyway, I think Tommy's suggestion is eminently reasonable. Third point, can you go to the next slide? This really seemed like it might be okay, because if you're only getting really small packets, you don't have like that much inflow, and any real application you're trying to shut down is going to send you big packets. And so I just give it, going back to principle 1 or principle 0, depending on what kind of computer scientist you are, that seems like it'd probably be just fine. And my fourth point is I concur with I think Nick's point about randomization, random being bad, and in that vein, it's possible to have a deterministic algorithm whereby you hash the incoming packet and then you blah blah.
Okay. We're going to close the queues, John. If you want to get in now. Okay. Go ahead.
Okay. Yes, I was going to basically say what Edgar said for me, which is we use something we call a time wait list and do exponential back off for stateless reset to try to avoid situations like this. The other is on packet duplication. We have seen this before in real networks. It basically never happens unless it happens all the time. So you have like one broken switch that just basically sends every single packet to everyone or something like that. So it's like a very bimodal thing where like everything's fine until like all of your servers are DDoSing each other. And then we also had to solve this exact problem for client initial a long time back because the keys weren't asymmetric, or there was no way to tell the difference between server initial or client one. And in that case, we actually decremented the TTL. So we would like make sure that the TTL decreased as the client initial went back and forth. And I wanted to add that that's one potential mitigation is you can copy the TTL in, and that does ensure that there's no infinite loop. Yep. I don't know if that leaks too much information, but it's a very simple solution and it totally works.
So hi, Brian Trammell. I was basically going to come up here to say what Ian just said. There's another thing that you could do. So I really like the simple solution. There's another thing that you could do to the simple solution by tweaking the size of the stateless reset and saying that not just saying don't send it if it's smaller than the packet that was received, but say that the stateless reset must always be packet size, at most packet size minus something, and then you essentially, the TTL itself is encoded in the packet size. If you can, that requires probably a little bit more rethinking of how stateless reset works. But what are the packets that are smaller than stateless reset?
The problem here is that the stateless reset has to be large enough to be plausible on
Right,
any connection, and you don't know how large the other side has set its connection ID to be.
Oh,
so
right.
you have to
Okay,
cover
yeah.
the largest
so-
possible connection ID the other side could have, which means they end up being something in the order of 40 octets, 37
Right.
octets. I think.
Okay, so my idea sucks and Ian's idea is awesome. Do that.
Yeah.
Manasi Deval, Intel. So there, if we compare this behavior to TCP, with TCP, we see there are some state machines that are triggered at connection termination. So, and they are primarily, at least some of them are around vSwitch offload, terminating tunnels, removing state in the software based on the termination of a connection. So it would be definitely good to have this deterministic, because otherwise it leads the software to basically go through a huge number of flows. And in concept, it's simple, but the scale is quite huge. So it's not very easy to say like just run a timer and delete things that have or expire flows. So that's my feedback here. I would prefer it to be deterministic.
So for a long time, a significant part of me has held the thought that stateless reset is something we should jettison altogether, because we have a nice, beautifully authenticated protocol, and allowing someone that's clearly not participating in that to influence your behavior just feels wrong. I've been convinced that operationally, like you can't work around this at some point. But I think that does argue for the simplest possible solution here. The probabilistic things, it's a lot of machinery for something that, for a party that's not really participating in the protocol, and that's concerning, right?
Jen Iyengar, this to me does bring back the question of do we really need this to be symmetric?
Symmetry doesn't help us here.
No, it
you can
does.
point two servers at each other with this.
Oh, right. Of course, we have that problem. Yes.
Yeah.
Sorry, you're right. You're right. Yeah.
Okay. All right. So I like the suggestion of the TTL. That may not be accessible to a number of people, but it's certainly something we could strongly recommend, particularly in this sort of too small case. And so
we're talking about the IPTTL, right?
IPTTL.
Yeah.
Yeah. And so then you're acting as effectively, it'll just keep driving itself down to zero and eventually won't get through. All right. Thank you.
Okay.
That's all I've got.
Thank you. You may leave the pink box. So next up, we've got 3 more issue presentations. Mike, if you can make your way up. Connection ID, then HTTP, then recovery. I'd like to finish these 3 up in the next 25 minutes if we can. So connection IDs.
Okay, so we've had connection IDs in QUIC for a while. They're very useful for helping a connection survive changes to the for tuple, and I think we've all had these.
Oh, yeah, please.
We'll see if it actually works for me this time. All right, good. I think we've all had a lot of intuition about how we think they ought to work, and it turns out that trying to specify that gets kind of hairy. So where we started out in pre-PNE land was that each connection ID was in sequence, had a specified packet number gap to help avoid having the packet numbers give you linkability, and then they have a stateless reset token. Problem with that is you get head of line blocking, because if you miss one of them, you can't use anything further down the list because you have to know the cumulative packet number gaps. And once we had probing and connection migration, it gets really weird trying to sort out, well, I use this other connection ID with the packet number gap on the other path, but what do I do here on the main path where I haven't changed connection IDs? So once we had packet number encryption, we said, great, we can get rid of all of that, and packet numbers are just this cloud, not packet numbers, connection IDs are this cloud of things that we've received. We can use any of them. All right. We can use any of them anytime we want. Head of line blocking isn't an issue. Great, this is simple. But to break linkability, if your peer changes, then you also need to change. And exactly how do you figure out that the peer's change was in response to your change and not the peer changing at the same time, so you need to change? And I started trying to write down the rule of how you would figure that out, and I couldn't. And if somebody implemented it and actually did figure out a rule, that would be nice. But what we came up with was we actually do need that sequence number. Ecker?
So it's not entirely clear to me that when your peer changes CID, you need to change. So, I mean, the peer might change the CID for fun. Well, you need to change your CID. The time you need to change your CID is when the path has changed.
Mm-hmm.
And so the question is the peer changing the CID the only signal you have the path has changed? And it's not clear to me that's true.
So the spec recommends that you change your connection ID when you think there might be a NAT rebonding, like you've been quiescent for a while.
Sure.
And if you want any kind of unlinkability across those, if your peer just responds with a connection ID you were using to your new point of connection.
No, I understand that point, but what I'm saying is that so you have A behind a NAT and B not behind a NAT,
Mm-hmm.
and A thinks he might have had a NAT rebinding, and so he uses a new CID, but B knows he didn't have a NAT rebinding, and so B knows that the paths haven't changed,
right.
and so B responds. So in that case, you don't have to change your CID. So it may be the case that the only way to detect this, you have to be conservative, but I'm not yet persuaded that it's not possible to determine whether the path has changed without using the CID as a trigger.
Are you using A and B as two different clients, or is the peers talking to each other?
I'm saying they're peers.
So if B knows that,
B knows that A's IP didn't change because it can see the incoming packets.
Right.
So Martin Thompson, I believe we're being conservative, and we're also, in this case, when A changes their connection ID, they might want to appear to be C, so that the folks on the network might think that there's other people behind that NAT, for instance.
No, I appreciate that point, but what I'm saying is that if you receive a new connection ID from someone whose address has not changed, then it's not clear to me that you actually have to change your own connection ID.
Oh.
And so that might get you out of this lockstep condition.
I think we chose the lockstep condition because it was convenient for other reasons. That's all.
Okay, but I guess, but we're back to here about how it's inconvenient. So I'm like, so that's why I guess like this is sort of like, I guess I'm trying to figure out like how much this is a historical talk and how much this is like a motivation for particular design. And if it's a historical talk, I'll sit down and shut up. But if this is like driving us towards like some particular design, like as a motivation, then I'm not going to sit down and shut up because I'm not convinced this is the right way to go.
So this section of it is historical of how we got to what's in draft 13.
Okay.
But it is new in draft 13, and if you think it was a mistake, we could revert it and take a different direction.
Well, I mean, just like what I'm seeing, like I see you about to add some epicycles, and so like that's why I'm asking, like before we start adding epicycles, like whether we should be like going back to that first principles as opposed to adding epicycles. And so I guess like one thing it's like, I mean, like purely designing off the top of my head, which means the apply is wrong. Like why can't you just strict the rule to update? Like you only update when you believe that Clear has also sent you a new transport parameters, new transport address than the one you're currently receiving the CID on.
So Jana Iyengar, I don't know that you need to. You could easily assume that all of these are associated with path changes, right? And I think the problems or whatever you're going to say is still going to hold true. Like each of these events, whenever the connection ID is changing, if you assume that the path is also, the network is also changing, that's a fine assumption if you need to make that assumption. Because the text in the document right now requires the peer to change the connection ID every time it sees a connection ID change.
No, I know, but the reason you're counting to infinity is because everybody's ping-ponging the changes, right? And so what I'm saying is, it's like imagine the case where the addresses are completely stable, right? And one side changes because, as Mike says, he thinks he may have had he's been offline for 45 seconds. He might have had an outright binding event, and so he sends it, but he hasn't changed. Then if the other side doesn't respond with a change, then you won't count to infinity. And if you have changed and you do send it, then like I think you can put that from the initiator's, so from the A's perspective behind the NAT, when he receives the second CID, like he doesn't have to change again because the other guys' address isn't changed.
So that's fair.
Just let's stop. Let's let Mike get through his presentation and then have our discussion.
So I think that is an interesting suggestion. Let me talk about the other issues that we have with this model, and it may be that going to that would solve more of them, and that's one of the solutions that can be on the table. So there are some advantages to having a sequence number. So that's what we have in draft 13, which says that there is a sequence for each connection ID that gets issued by your peer, and that makes the behavior pretty easy to specify. If you're starting a new path, then you have to use a higher sequence number than you have ever used before for this connection. And on each path, you will never send a packet where the connection ID sequence number is less than the highest you have ever sent or received. So that forces the ratcheting behavior on a per path basis. So to give a quick example, I'm using A, B, and C so you can keep track of the sequence numbers. Multiple paths are hard to draw, so forgive my bad drawings. So we have a connection. Both sides are using connection ID A, which is a different value in each direction. And also they're doing some probes on a side path to get ready for a potential migration. They use B for that. The fact that you probed doesn't change that you're using A on the main path. And if on the main path you change to C, the other side moves to C, that doesn't change the other path, you can stay on B. If the other side tries to roll forward again to D, but for some reason you don't have D, you just go to the next one that you do have, and then the peer has to match you. So that way you have consistent rules for how you move through the connection IDs that have been issued. So that simplifies a lot of the specifying what you do when. But there are some problems with that. Let's say you're using A on the main path, and you have lots of other paths you want to probe. So I'll use B, C, and D because I just got those from the peer. But they all get dropped because those paths don't work. Now one side says I have no spare CIDs. The other side says I don't need to give him any more. He's got 3 outstanding. So Yep.
Ah, you found a new mode.
Indeed. So it's possible to become unclear whether a peer has actually used the connection IDs that you've issued him and may need more. That's one problem that we still need to solve in this model. Also, if the only packet that you ever sent with a given connection ID gets dropped, and eventually you forget about it, but it's not actually dropped, it's just severely delayed, that can trigger a stateless reset. So there also needs to be some kind of coordination between the peers when they're no longer going to consider a particular connection ID to be associated with this connection, or you get into some weird states. An easier place for this to happen would be, let's say you use that to probe on a side path, and one side considers the path to have been abandoned because you haven't probed it in 2 minutes, but the other side says, well, I just haven't sent a probe lately, but that's still a path that I have available and I know it's validated. So if you have a long-lived connection and you're rotating connection IDs frequently, it's not practical to remember all the connection IDs you've ever used, particularly if the peer can force you to move to new connection IDs. That's also especially true if all the connection IDs have to be plumbed into the load balancer so that they get routed to you. But if you can't coordinate when it's safe to forget a connection ID and remove it from state, then you can trigger stateless resets. And there are cases when you might actually want to expire a whole swath of CIDs. For example, let's say it's encrypted, you're doing key rotation, you're about to rotate again, you have to make sure that everything that was done with not just the previous key phase, but the key phase before that, will never, ever, ever be seen again for the life of this connection. So there's a PR right now for 2 more frames that say, hey, I need more CIDs, and hey, I'd like to get rid of these CIDs. There is another proposal for how you get rid of connection IDs, which is to say that there's a certain number outstanding at a time, and you can just auto expire based on how many new ones you've gotten. I think that we'd have to work through that carefully because, again, there's confusion about which CIDs does the peer actually have and agree not to use, but that's also a possibility. So this is a proposal that I think we need to sort out. I think this is true even if we don't force the peer to advance in lockstep. So I'd like to know how we solve it in that world if we want to go there.
Janayangar, I don't think the retire connection ID works. Reordering.
Reordering
can cause race conditions. Like the server could send a stateless reset and then send the retire connection ID, or the retire connection ID is sent, dropped in the network, retransmitted, but before that, the stateless reset is sent. All kinds of reorderings.
The way this is in the PR is that the client will stop using a particular connection ID once it receives the frame, and the server will forget it once it receives the acknowledgement of that frame. So you won't get a stateless reset until you've act. Now, if it's reordered across this, okay, so the client sent it before the retire CID frame arrived.
Yep.
But then the server receives it after the ACK, is what you're saying?
Yes.
Okay. So oh, no, actually the solution to that is when the client removes the CID, it also removes the stateless reset token. So it won't recognize that stateless reset as belonging to this connection anymore.
All right.
Go ahead, Martin.
So, Martin Thompson, I'm not a huge fan of this, and I know I proposed an alternative design, I think that ultimately was Kazuo's suggestion originally, which was that endpoints would advertise an absolute number of connection IDs that they were willing to remember.
Right.
And that number would be the sum of the ones that they would be willing to remember, plus those that might be in flight. And that would work, I think, much more simply than what you have. And the only thing you would then need is, because we have this reciprocation requirement, you would require, if I sent you a connection ID with an ID of 10, you would have to make sure that you sent me all the connection IDs up to 10 in response. And then it says, I think that'd be a simpler design.
I agree that it feels simpler. I would need to work through it. I think some of these problems about getting confused of who has actually sent what will make the peers not agree about what the current set is. But there may be ways around that. So
I don't think they have to agree, actually, but not entirely. But the only thing that's important there is to remember that if you support 10, if you say that you support 10 different connection IDs, you have to count the ones that you've sent but not had acknowledged yet in that set. Otherwise, that you have to assume that the other side. Sorry, you have to assume that the other side remembers 10 plus the ones that you haven't had acknowledged yet.
So this is very complicated and it made my hair fall out.
Don't blame me for that.
So first of all, I think given that we have a number of proposals here, I think trying to merge this at this moment is going to be very problematic. And frankly, I'm starting to think we need a Tamarin model of this to figure out whether or not it's going to break, because I'm having a lot of trouble reasoning about it, which really worries me, because these things my experience with these things is we spend a lot of time building things, and then about 2 weeks later, Kazuo sent some email saying this is totally screwed up because of this use case. I'm much as I appreciate that service, we could have more I worry about having the reliability of our protocol predicated on Kazuo having a brainstorm. With that said, I think this would be the first time we declared the semantics of a piece of the protocol dependent on receiving acknowledgement from the peer, and that makes me kind of sad. I normally think of packets going into some bucket where they just gradually migrate to the other side, and then acknowledgements remove things from the bucket. And so having that fed back upward to me, so I have to do some other action, scares me. So I think this would be the first time we've done it. If it's not, if it isn't, we should take those things out. And if it is, we probably shouldn't start.
I think it isn't, but we have previously taken out the other instances.
It doesn't sound like we're going to conclude this today, so I'm going to cut the queues. Go ahead.
David Skenazy, Apple. I'll echo Ecker's point about this being pretty complicated and starting to lose hair. Also, most clients, in my understanding, correct me if I'm wrong, will probably be sending zero-length connection ID. So sounds like we're building a lot of complexity that won't necessarily be used. Just something to consider. Please keep it simple.
Gabriel Montenegro. So question that's come up is, could this be simplified a little bit by not requiring the need, just with retire, when the action of retiring might trigger your peer sending you new ones up to X or whatever?
Yeah, I think that's another flavor of you have a certain number that are outstanding.
Right.
The other way of doing it is the action of issuing new ones retires old ones implicitly, but either way, and also the peer has to match the number that you issue.
Yeah, although I think you did justify why retiring specifically some would take care of the delayed packet. That would be more explicit.
Yeah. Okay.
You had one more slide, Mike. Do you need it?
Can I propose a way of moving forward for this?
If you can do it succinctly, yes.
Yeah, I think we need a design group for this.
I was thinking the same thing, yeah.
Okay.
And perhaps get it together and talk about it in New York. Is that a reasonable time frame?
Okay.
Show of hands who's interested in participating on such a thing? The usual suspects? Okay, Mike, do you want to take charge of collecting those folks together?
Sure.
Okay, great. So if you're interested in helping out with that design team, talk to Mike, and we'll expect to hear back before New York.
Okay.
Okay.
And then the last slide is just to say that in addition to the things that could actually cause your connection to break, there are also some annoyances involved in this. The spec currently says the CID from the handshake has a sequence number of -1. Some people don't like negative numbers. The server's preferred address also gives you a connection ID, and it doesn't actually say what sequence number that is. And the handshake connection ID doesn't have a stateless reset token for the client. And if you want to be able to define one, how do you do that? So these are all other less connection critical CID issues that have been discussed on list.
Okay, thank you. So stay there.
Okay. Now I'm trapped in the box.
Now you're trapped in the box. Welcome to the box. Next up is HTTP. We have this, and then we have recovery. So I'd like to try and at least fit both in. Let's see how we go. Come on. Go ahead.
All right. So quick overview of notable changes since London. I will try to move through these at a fairly rapid pace so we can get to recovery. If you've read the drafts, this should not be news to you. The HTTP frames no longer define flags on every frame type. Priority was the only thing that was using it, so now it's just part of the priority definition. Yay, saving a couple bytes. HTTP2 uses zombie streams that were never opened and are implicitly closed to maintain the priority tree. That has some not happy implications on server memory consumption, and also QUIC can't implicitly close streams. So HTTP over QUIC now has a priority placeholder explicitly defined. And also, along with that, we now have to account for the fact that 0, which used to mean the root of the tree, is actually a request stream, so you have to have something else to handle that. This lets you do more aggressive pruning on your server's priority state because you can keep track of which nodes are inactive, active, or placeholders. Placeholders never get removed. You can remove and trim out the inactive ones with some fairly simple rules, like you can take out any branches that are all inactive nodes. You can collapse down any interior regions that are all inactive nodes. And the client can predict that you're going to do this, and so it helps the server and the client have a consistent view of the priority tree from both sides, where in H2 it was actually fairly easy to get confused. The other big change in HTTP is that we have now put a type byte on unidirectional streams. They are essentially self-describing. The first byte tells you what type of stream to expect it to be, and this is a point of extensibility. We have 4 types defined currently, 2 for QPAC, and then 2 in the core spec. 1 is for control stream, the other one is for push. If you don't understand it, abandon the stream, which may involve a stop sending frame at the QUIC layer. And in terms of recommendations to extensions, if it's data that develops over time, like the QPAC table, use a stream. If it's data that you have in your hand all at once, go ahead and define a frame like you did in H2. But this gets basically the same semantics as new frame types. When we discussed it in Shista, the hum was roughly split between yes, we want this, and we're not sure yet. We had a follow-up discussion on the list that was mostly positive. There were some drawbacks that we know come along with this. Debugging without tools gets a little bit harder because now you can't remember what stream ID belongs to what stream ID is the control stream. You can't look at a unidirectional stream and say, oh, of course that's push. But considering we're talking about an encrypted binary protocol, I'm really impressed if you can debug it without tools anyway. And there's the slightly annoying state that if you receive data on a stream out of order, it becomes open, but if you haven't received the first byte, you don't actually know what type it is to assign it to a handler. Everybody that I've heard who has tried to implement this just has a handler whose job is to collect unknown stream types, and it holds it until the first byte is readable. This has an interesting implication on the structure of the document, which is that push is now more or less separable. Push streams are just another unidirectional stream type that you don't have to support. And if you receive, you're never going to get one anyway if you don't send max push ID greater than 0. You don't have to understand max push ID frames or generate them if you don't support push. Priority explicitly has push IDs as something that can be prioritized, but if there are never any push IDs, you don't have to care about that combination of bits. We removed a setting that said I support push or I don't. If we add that back in as a master switch, push starts looking kind of like an extension like any other extension, which is kind of a nice property for the protocol to have. So if we want to add the setting back, even if we don't, I think this is where push stands in HTTP over QUIC. And past that, when I first did the slide deck, there were no other non-editorial, non-parked, non-QUIC v2 issues in the HTTP over QUIC spec. Then I opened one. This is, I think, just leftover, we missed something. So QUIC says for 0RTT, if the server accepts 0RTT data, the server must not reduce any limits or alter any values that might cause the client to accidentally violate its true settings when you finally get the transport parameters. That's very sensible. HTTP over QUIC actually has what we decided way back in the Tokyo interim and then later decided was a bad idea in the transport, which says the server will permit the client to violate its settings temporarily until it knows the real settings, and then the client has to retroactively comply. That gets really ugly with things like QPAC, where you can remember that the allowed table size used to be 64K, so you say, all right, I'm going to use 56K of that, stuff a 32K cookie in there, send a request using that cookie, and then you see the settings frame and find out you're allowed 4K. What do you do at that point? You can't reduce the table without evicting the value for a stream that's already in flight. And you could kill the request, but then you kind of miss the point of 0RTT. And I think the right solution here is we got it right in transport and we just missed updating the HTTP doc. But that has some architectural implications, which means if we were to make HTTP match the transport's requirements, now you have to ask HTTP about a particular 0RTT ticket, whether you're allowed to accept 0RTT on that. And that is also kind of painful. So I think the question to the working group is, which type of ugly do we prefer? And I'll note that the server already has to dig out the old HTTP settings to figure out if the client is violating the old ones and to distinguish between malicious versus confused.
Eric Riscola, I mean, I feel like the premise of QUIC is tight integration between the layers. And so, like, while it is like disgusting, like it seems like that's the disgusting we decided to that's the, I mean, like it. I think I suppose he's gonna say the same things. I know he's like thinks everything should be top to bottom. But I mean, like, you know, our philosophy I think is to have tight integration. And so when we discover a new point of tight integration, let's go with that philosophy generally, unless we have to, unless there's some really good reason, as opposed to like a new piece of like grossness that we haven't like previously like decided to accept. But I mean, I don't feel strongly about it, but that'd be my instinct.
Okay.
So, but I completely agree with that as well. But getting flow control right and other components right is like hard enough in its own. We don't want more edge cases.
Okay. I hear unanimous. Let's do ugly and make the layers match. Great. So once I fix that, we will be back to there are 0 actual functional issues open against the doc. So please implement and find the rest, because I know they're not all gone.
Okay, thank you, Mike. May you leave the pink box. So it's 11:43. We've got recovery. We want to talk about forward planning, and if we have time, Marcus has some updates on the spin bit. I don't know if we're going to get to you, Marcus, but we'll try. It depends on how much people want to chat. Ian, can you do 5 minutes?
I can do whatever you like.
Gold. I want gold. Yeah, if you can just limit yourself to 5, I think we can do it.
I should be able to do that. So there are a few editorial issues open for recovery, but I tried to pick out some of the non-editorial ones that I would like to resolve at some point before V1. They don't need to be resolved today, but at least start thinking about them. Next slide. So this one, hopefully we can resolve right now. The early retransmit threshold is currently 1/4 in the doc. That actually follows, I believe, the at least initial Linux implementation. I don't know if that Linux is still using 1/4 for early retransmit. On the other hand, in the other spots in the doc, we recommend 1/8 of an RTT of rare-to-ring threshold. So the inconsistency is A, ugly, and B, I have data in MapRG tomorrow that indicates probably an 1/8 is a better number for QUIC anyway. So my proposal would be to make both of them 1/8 until we have some more data, both for consistency and sanity, and that also allows us to use a more rack-like logic and combine the early retransmit timer in with the time-based loss detection more cleanly.
Gary Fairhurst, very quickly. We talked about this in TCPM, where the mechanisms are used with TCP. Is it not better to just do the discussion in one place and be over with it? Or do we want to talk about congestion control separately and recovery separately for the two things and just use 2 meeting slots? Jana.
Jana Iyengar, we could certainly discuss this in TCPM also. Just to be clear, I think we are building our own mechanism. QUIC is building its own mechanisms using TCP ones as informative. These are basically similar but not the same mechanisms.
Sure. And that has big issues, I think, that we really, really need to delve into. So this makes it complicated when we really don't know what we're doing with TCP even, and then we start doing it again here. But I don't want to take up time, but it's just hard to do this.
Okay. So the proposal is to do this now, and when you say more data, you mean before we ship the final product, right?
Yes, and then if people come up with data in 3 months or 6 months, then we can of course reevaluate this with more data. But right now we don't. All the data I have says 1/8 seems fine. So if anyone does not object, I will do that and close this. Next issue. Max data before sending an ACK. This is actually kind of important. This came up with the ECN conversations. The current text attempts to be a little bit more general than the default TCP implementations, in that it allows you to send ACKs less frequently than every 2 packets. In a lot of networks, this is an excellent optimization and decreases the ACK flow rate very substantially. Experimental evidence shows that this can be very valuable. However, Reno is also the documented congestion controller, and Reno is ACK clocked. And so you will end up with slow start growth and a few other issues if you use Reno and only ACK, say, every 20 or 40 packets. And so I think we need to kind of reconcile those two things of, if we're going to recommend Reno, we need to have reasonable default acknowledgement behavior. And the proposal that John and I came up with was to send a transport param indicating the sender gets to indicate how many bytes the peer should receive, retransmittable bytes, before sending an acknowledgement. And so the default would be TCP style, maybe like 2,400 bytes or 2 packets, whichever one we decide.
This is Yoshi Nishida. Quick question. Have you ever considered appropriate back counting? Because this topic is a little confusing to me. If you use appropriate by counting, this should be okay. Is there any opinion on that?
So this isn't really as much about appropriate byte counting as it is about the fact that right now the doc literally says, as long as you adhere to your delayed ACK timer of whatever you say it's going to be, which defaults to 25 milliseconds, you can ACK as infrequently as you want. There's just no prescription whatsoever about say hacking every 2 packets or hacking after every n bytes. And so I'm proposing adding that back in, but allowing the peer to specify what they want the receiver's behavior to be, because for some congestion control algorithms, PCC and BBR, for example, it's completely fine to send an acknowledgement, say like after every 10 or 20 packets. And for things like Reno, it tends not to work as well. So that makes sense.
Okay. Do you have any clarification text in the draft? I think I need to understand more clearly.
We are running out of time.
It's okay. These are the 2 most important issues.
We can
Okay.
take it offline.
Okay.
Sure. You're okay to close.
Jana Iyengar. Yoshi,
Thanks,
I think this might help you understand the difference. Quick does not require you to ACK after every 2 packets. So you could actually ACK once every half RTT if you want. So the main point here is to allow the sender to compensate for that in its congestion controller by saying, I can't really compensate, so you must send acknowledgements every 2 packets or something like that. So this is really like the sender saying the receiver how frequently it needs acknowledgements back from the receiver based on bytes.
So I've got Marcus and then Praveen, and then I think we're going to close the queue out of necessity. Marcus?
Magnus Westlund. Is this bytes or packets?
We discussed both on the issue. I think we're leaning towards bytes at the moment.
Okay, I will join that discussion then. Okay.
Okay. Praveen?
Hi. So because of appropriate byte counting, we don't really need an ACK every 2 packets. We just need an immediate ACK if you process at least 2 packets in the current batch. So we can still do stretch hacking. Like if there's bulk data flow and you got like 100 packets, you can still send 1 immediate ACK. You don't need to send 50 ACKs. And I think that's still good enough. So that's why we should mandate that you should generate an ACK at least every 2 packets. But it could be more.
Right. The proposal would be to add text actually that allows you to, if for example you can do receive MM message and suck 40 packets out of the kernel at once. For
Yeah,
example.
you should not delay the ACK if you got it 2 packets.
I don't think I understood that very well, but I think I'm running out of time, so I'll follow up on the issue or online with you.
Sounds good.
Okay. Thank you very much. Okay. I've left a sliver of time here at the end so we can talk about the future. So planning for future activity in the working group. We have a September interim planned in New York City. It's on the website. Registration is going to close in 3.5 weeks, so if you haven't registered yet, please do so very soon. It is, I hope we're not going to be space constrained. It's the same size of venue approximately as we've had before, and the number of people coming has been falling, so that's hopefully we'll be okay. We're going to do an interop beforehand, as we always do, and we're going to need to figure out the scope of that interop work, so we're going to need a 7th implementation target. Are you sure?
We already have a 7.
Okay, because the website says 6. We need to update the website then. We need somebody to own driving that definition. Is anybody willing to do that, Ecker?
Sorry, what did you say?
Martin Thompson, I proposed the same one that we had last time, because what it says is draft 13 with a couple of tweaks, unfortunately, and please, 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 HTTP.
So HQ, yeah, more emphasis on HQ.
So we did 13 plus 1498. The editors, so so whether you propose a 14 or not, you propose we just go with that like patch applied version. Okay, unless you want to produce a 14 that happens to have 1498 in it, nothing else.
So we could potentially do 1498 and nothing more in the new revision if people want that. Let's discuss that on Slack.
I guess what I propose is something which is semantically equivalent to that, and I'll leave it to the editors to sort out how it's constructed.
Then, if we get all of the changes to retry in, I think it might be a reasonable thing to do that. Yeah.
Well, that would be the nice thing about that is it's a bolt-on. So if you don't do it, it'll be fine.
Okay.
So I can help you update that.
We can take this to the wiki and to the list if necessary. So talking to Lars, talking to Spencer, talking to the editors, we think we're getting close to done. And that's a message that we want to send to the working group very clearly. Our chartered milestones are November. There still seems to be an intent that we want to try and meet those milestones in spirit at least. We may, of course, come across issues we can't resolve by then or have further discussions, but there still seems to be an intent to try and ship it on schedule. So if you haven't started reviewing the documents, now would be an excellent time. We anticipate the editors are going to do, not only we have a fair number of issues to resolve, as you heard, we also have a fair amount of editorial work to do. They're going to try and make the documents more reader-friendly. So don't feel like you need to go in and pick apart the grammar or the spelling or anything. But in terms of what the documents contain or don't contain, please start looking at that with the eye that we're going to be finishing pretty soon. We had one big change as a result of previous meetings with the Stream Zero work, and we've incorporated, and that's good. I think that it's fair to characterize it's going to be progressively harder to make a big change as we move down the road towards completing. So please do keep that in mind. I think we talked briefly before. We're talking about shipping the base drafts. We're talking about shipping the ops drafts possibly at the same time, or at least that's the default. If we want to vary that, we need to come to some agreement about it, and it doesn't sound like we have that easily yet. We have the invariance draft as well, which we'll probably do a slight refresh on, but otherwise I think it's going to stay the same. Those will all ship at the same time. The elephant in the room is the spin bit, which is probably why Brian's standing up. If all goes to plan, Bangkok is we're gonna make that decision. We said before we need data and experience that it demonstrates it's useful in managing operating networks. So if you are gathering that data, please bring it to the working group, ideally before Bangkok. It gives people time to look at that data and get comfortable with it. And feel free to talk about it on the working group list if you want to coordinate with other folks. But I don't think we're going to be delaying last call if we don't have that kind of data. This is a decision we need to make to ship.
May I make a friendly suggestion here?
Sure.
So we've taken in the past information about the spin bit off the interim agendas, just so there's no perception that you have to actually invest a lot in order to do this. I've noticed a lot of the people who are doing sort of core work on the spin bit are at the interims anyway.
Sure.
So maybe we should revisit that for New York. So because we blew the schedule today, so we don't really have a time to talk about it, and a time to talk about it with a large part of the working groups would seem to be useful before we spring it in Bangkok.
We've kept it out of the interims mostly so that it doesn't consume too much of that time that we have other issues.
I think we're done with time consumption at this point, right? So
sorry?
I think we're done with time consumption.
I hope so. Yeah. Also, practically, it becomes very hard to find a venue of all the people the people who might be interested in that discussion. We already have problems with finding venues, and that would make it much worse. I anticipate carving off a very healthy amount of time in Bangkok, and probably even holding a side meeting beforehand to prep everybody and get some discussions going.
All right, I will miss you guys in Bangkok. That's kind of unfortunate.
That's sad to hear, Brian. If we can have a controlled discussion in September that somehow moves us towards having a more successful conversation in Bangkok, I'm open to talking about it. I have concerns. So, we've also, if we finish up in Bangkok, the idea is we go to working group last call then. The WGLC may collect some issues we need to discuss. IETF last call, if it happens in a timely fashion, may collect some issues we need to discuss. So we may need an early 2019 interim. Lars and I have discussed this, and we think what we're going to do is start putting together the arrangements for such an interim, January or February, something like that, but not actually pull the trigger on it and say we're going to do it until after Bangkok, so we know if we need it. We don't want to waste people's time. But just to give you a heads up that that's the way we're thinking. We've been doing this pace of having one interim between each major IETF. And if we do that, it's going to be in Europe and Asia because the next one's in the US. Any questions about that? Okay. One other thing that's come up, we have 2 minutes left, is the name of QUIC itself, from what we've observed, still causes confusion amongst implementers, amongst people who are writing about it in the press. potential users. And this has been bothering us for a while because there's Google Quick and IETF Quick, and we say G-Quick and I-Quick, but we don't do it consistently, and people outside of this room don't use it at all. Talking through this, changing the name of Quick at this stage doesn't seem realistic. I mean, after all, we have really nice stickers. So instead, a member of the community made what we think is a very good suggestion, is to maybe, when we ship this thing, when we ship it, we'll call it Quick version 2, with the idea that Google's version of Quick was version 1. So I'm not going to open this up to a working group decision. I almost consider this an editorial issue. I wanted to give people a heads up about that. If it gives you heartburn or you have concerns, come and talk to Lars and I.
Just a little bit of comparison from Acme. We had the same discussion about renaming because we had Let's Encrypt Acme and IETF Acme, and they were mutually incompatible for a long time. And what has ended up happening, even though the working group decided to do nothing, was that the industry is calling IETF Acme V2. And
Right.
so calling it V2 is a natural thing anyway.
Yeah. Okay, thanks. That also has another implication. We've had this background discussion about Quick version 2, what the next thing is after, Quick for HTTP. Obviously, that would become Quick version 3 or something else. But since we're now talking about getting to the end of this work, those sorts of conversations become more in scope, and we should start talking about what the thing after we ship Quick version, I was about to say 1, version 2, is going to be. So please talk amongst yourselves, talk to Lars and I, and we'll start figuring out what that next phase of work might look like. I think we're done for today. So hopefully we'll see a good number of you in New York City in September, and then of course we'll see everyone in Bangkok. Thank you. Oh, and Marcus. So Marcus had slides on the spin bit. We didn't get to those. They were kind of requested at the last minute. Marcus, do you want to use the room to maybe give a presentation for those who are interested because it's lunchtime, or you want to just send the slides to the list? Any preferences? I'm sorry. Where's Marcus? There. I'm sorry. I'm confused. That's why you look so confused. Sorry. Yeah? Do you want the room? Yeah? Okay. We're all vaguely Swedish.
Yeah, click V2 and the number is extra.